Hi friends, very good afternoon to one and all. So in the last two videos we have seen two basic concepts. One is the force on a moving charge when it is placed in a magnetic field. This is the first video we have seen on force in magnetic fields, and the second thing is we have seen force on a straight and finite current carrying conductor. We have seen in the last two videos, straight and finite current carrying conductors. So these two we have seen in the last two videos. One is the force on a moving charge in a magnetic field, and the force on a straight and finite current carrying conductor in a magnetic field. These two we have seen in the last video. So in the last video we have seen that the force expression on a finite conductor, we got this as F bar is equal to I times L bar cross B bar. Okay. So when I place a conductor, a straight and finite conductor whose length is L, this is the straight and finite conductor which is carrying a current of I. When I place this in a magnetic field B, how this conductor experiences force is expressed by this equation I L bar cross B bar. So if we expand this cross product, we will get this I into, we know that the formula for A bar cross B bar can be written as magnitude of A, magnitude of B, sine of the angle between A and B. So here in place of A and B we have L bar and B bar. One is the length vector and another one is magnetic field vector. So I can write this as ILB. Magnitude of L bar is L, magnitude of B bar is B. ILB, sine of the angle between L and B. So this is the magnitude of force. If you want to know the direction, I can write this as AN bar, because the direction of force is always normal to the plane containing length vector and B bar. In this way we can find the force on a finite current carrying conductor in a magnetic field. Okay, so with this we have got some basics of magnetic force. Now we will study a new concept in this video. So let me know what is that new concept. The concept is force in between two differential elements. Okay, force in between two differential elements. Differential element in the sense differential current carrying elements. Differential current carrying elements. Between these two current carrying elements, how to find the force, that we will see in this video. So in order to find that, I am considering two conductors, two current carrying conductors of arbitrary shape. So I am considering this is one first current carrying conductor. Okay, so let us give the name for this conductor as 1 and give the name for this conductor as 2. This is carrying the current of I1. So first current carrying conductor. Okay, so I am assuming the current carrying by the first current carrying conductor as I1 and the current carrying by the second current carrying conductor as I2. Let us assume like this, and I want to find the force in between these two current elements, differential current elements. If you observe, because of this current carrying conductor, because of this first current carrying conductor, you have a magnetic field which is produced. Let us assume that magnetic field as B1. And because of the second current carrying conductor, you have one more magnetic field which is B2. So like that, first current carrying conductor is in the magnetic field of second current carrying conductor. So first current carrying conductor will experience a force due to the second current carrying conductor. Similarly, the second current carrying conductor is now placed in the magnetic field produced by first current carrying conductor. So second current carrying conductor also experiences a force. Due to this reason, these two current carrying conductors experiences some force. We need to know how to get the expression of the differential force, because this force is not the total force. First we need to find the force between two differential elements. Hence this force can be taken as the differential force. Okay, so how can I know this? First of all, I am assuming the length of this small element as dl1 bar and this element as dl2 bar. Now how can I find the force? So let us assume F1 indicates force on first current carrying conductor. Okay, force on first conductor due to the magnetic field produced by second conductor. So F1 I am assuming as force on first conductor due to second conductor. Similarly, F2 is nothing but force on second conductor. What is F2? Force on second conductor due to first conductor. Due to first conductor. Okay, now how can I find that force? First of all, I want to know this force. This force is same as this force, because the as we have seen in Coulomb's law, that the force in between the two charges remains the same either for Q1 or for Q2. Similarly, the force on first current carrying element due to second current carrying element is same as the force on second current carrying element due to first current carrying element, because it depends upon both the currents and both the magnetic fields. Now first of all, I need to find df1 bar. What is meant by df1 bar? df1 bar is nothing but the differential force on the first current carrying element due to the magnetic field B2. Due to the magnetic field B2. So first of all, I am writing df1 bar as we derived previously. It is I1 dl1 bar. Is it right? Because I want to find the force on first current carrying element. Hence I need to write I1 dl1 bar cross B2 bar, because this is the force on the first conductor due to the field of second conductor. Hence for B we need to get suffix as 2, and for I1 for I and dl we need to get the suffix as 1. This is the differential amount of force, but we want to find the force due to only this small element. Okay, we want to find the force due to only this small element on this element. So I don't want to know the entire field. Due to this small second element, you will have again the differential field. So I am writing this as d of df1 bar. It is smaller than smaller, because df1 bar is nothing but the differential force on this small element due to the entire second conductor. But d of df1 bar is nothing but the differential force on this small element due to the second differential element. So that is the reason why I am writing this as d of df1 bar. Now how can I get this? I need to get I1 dl1 bar. Okay, I1 dl1 bar cross So here I need to take again dB2 bar. Okay, so this is the magnetic field due to the small element dl2. dB2 bar is nothing but the magnetic field due to the small element dl2, and this is the current through the small differential element dl1. Hence this is the differential amount of force on the small first element due to the small second element. In this way we need to understand. Okay, so now how can I write this? If I assume that this is the first differential element, consider like this, it is dl1 bar, and this is the second differential element, consider this as dl2 bar. Let us assume the distance between these two, I am just writing the magnitude, I am not writing the vector, because vector is different. When we move from 1 to 2 it will become r12 bar, when we move from 2 to 1 it becomes r21 bar. Both are in the same magnitude but different direction. That's why I am just writing only the magnitude of distance between the two differential elements. dl1 bar is the first differential element, if you observe in this. So this dl1 bar and this is dl2 bar. So dl1 bar is the first differential element and dl2 bar is the second differential element. The distance between these two is r12. Right? Now how can I find the magnetic field at this region due to this current carrying conductor? So this can be obtained from Biot-Savart's law, I think so. From Biot-Savart's law I can write dB2 bar as mu naught into the magnetic field due to the second differential element. So I need to get here I2 dl2 bar cross what you will get here r. So this is the final point and this is the initial point, so I can write r21 bar. Okay, magnitude wise r21 bar magnitude and r12 bar magnitude both are same. When I consider this as vectors, they are of opposite sign. So divided with 4 pi, is it right or not? 4 pi r21 cube. Okay, so this is the magnitude of the unit is Tesla. So this is the vector, this is the magnetic field due to the second differential current element at the first differential element. This is the magnetic field. Now how can I write the d of df1 bar? It is I1 dl1 bar cross db2 bar. Now just rewrite this equation. So d of df1 bar, the differential amount of force on the differential element due to the differential element. So it takes some time to understand. Just if you divide this into two current carrying elements and understand why we got this, then it will be easier. So it is d of df1 bar can be written as I1 dl1 bar cross, it is db2 bar, I1 dl1 bar cross db2 bar. If you see the previous I1 dl1 bar cross db2 bar. Okay, now it is I1, I am writing dl1 bar as it is, cross, in place of db2 bar what I can write, mu naught I2 dl2 bar cross r21 bar by 4 pi r21 cube, r21 cube Tesla. Sorry, this is force, right? The unit of force is newtons. So newtons. Now I am just rewriting this equation into a proper form. So I can write this as mu naught, is it right? As I1 I2 are scalars, 4 pi r21 cube is also scalar. I am writing this as mu naught I1 I2 divided with 4 pi r21 cube. mu naught I1 I2 divided by 4 pi R21 cube into, how can I write this? I can write this as dl1 bar cross dl2 bar cross R21 bar. So this is d of df1 bar. It is nothing but the differential force on the differential element due to the differential element. Okay, so in order to find f1 bar, I need to take 2 times integration. So just as these two current carrying conductors are forming a closed path, or a circular current carrying, not circular, they are of indefinite shape, but they are forming a closed path. So I can take this as like this. So it is mu naught I1 I2 divided with 4 pi R21 cube as it is. So it is line integral of L1 and another line integral of L2. Okay, I can write like this. So I can write first dl1 bar cross dl2 bar cross R21 bar. So in this way we can find the total force in between the two current carrying conductors. If you understand this concept, then only you can directly find the force between two parallel current carrying conductors, which is a very important concept and asked many times in more competitive examinations. Force between two infinitely long or two long parallel current carrying conductors. In order to find the force between them, we need to understand this concept. Okay, so I'm just giving a hint. First, you need to know on which conductor we need to find the force. As I want to find the force on first conductor, I just wrote I1 dl1 bar, right? And due to which conductor you have the magnetic field. Here the magnetic field is due to the second conductor, so I got B2 bar. You need to know what is B2 bar or what is dB2 bar according to Biot-Savart's law. So Biot-Savart's law formed the basis for all the concepts in magnetic fields. Okay, so in this way you can understand the force between two current carrying conductors, or concept behind the force between two current carrying conductors. Hope you understand this video. If you have any doubts, please post them in the comment section. If you really like this video, please share and subscribe among your friends. Okay, so thank you very much.